streaming. I decided to continue to work on the poker tool on stream at least for a little bit. It's gonna be a lot harder than I thought it would be, so I'm not really sure how far I'm gonna go with this. I already encountered several different problems, and it's gonna be a lot harder to build the simulations. So I'm not really sure if I'm gonna complete this or not, because not sure if it's worth it. All the time invested into this. So now I'm trying to figure out how to change the cards so that in the dictionary is in the right format. And I think I'm gonna open the file on there to see the format that it is and try to format it in this way. I'm gonna use ChatGPT probably. I think it's on tree building. And I spent some time manually as well putting the commands for this tree here. But obviously you can see that is just not a good way to do it by adding the lines manually. Unless I'm gonna get fixed bat sizes and then do this just one time, then I can get away with this. But obviously it would be better if I just figure out an algorithm to translate the bat sizes into these lines. But this is the part that I think is like too much work, and I'm not really sure if it's worth it. And I think that the reason why they don't make very clear on the thing is maybe because they are concerned that people are gonna like steal their algorithm or something like that. Because otherwise I don't understand why. Because they give you the commands, but then like they don't explain either this or both this and the ranges, like which order it is done here. So the only way to figure this out, I think, is to just change the bat sizes all the time and then try to see among all of them what are the things that are common and what things that change. But I think probably the best is to just use a template. And the algorithm would probably be taking the bat sizes from the thing and transforming them as a tree into a tree, where each node has the option that has 4 different options. So we create an algorithm that adds the different nodes based on the options and how they are gonna affect the pots. So pretty much a function that's probably does either depth first search or breadth first search, and then at each iteration it increases the size of the pot and adds the nodes to the tree. And maybe a combination of both of them, breadth first search and depth first search. Something like one of the algorithms that I saw for graphs, I think it's the zero algorithm, the A star algorithm, I think, where you put a heuristic to traverse. So it would be hard to do, I think, to get it in the correct order based on the data, based on the way that it is supposed to be here. And it's even more annoying because I was also testing to get the bat sizes yesterday and translating them into percentages, and then I got a lot of different bat sizes, which I wasn't expecting. I was expecting a lot less variation because usually I use the same bat sizes all the time. So that didn't make sense to me, which made me think that I might made a mistake on the way that I put there. But then I realized that there are 2 different stakes that exist on the data set, I think. And this makes the bat size vary based on the stake. So, but either way, I still think that there are a lot of different ones, and there might be a mistake on the way that I did the conversion there, which is another thing to worry about. And then I also got a problem with the position as well, because sometimes one of the players doesn't have a position. And I don't think I showed this last time, but I changed the way I solved offstring, the way I put the positions for each player. So that's another point that there might be something wrong, but I thought about it several times and I couldn't think about what could be wrong with the way that I did it. So the way that I did it is I initialize player count equals 0 and this lock equals true in the beginning of the hand, and also here. And then for each time that I add a player here, which is going to happen on this line, I increase the player count to keep track, obviously, of the amount of players. Then on this line is going to take the actions. So on round number 1 is supposed to have, see something. Round number 1 is supposed to have the actions for the preflop. So in my head, the thing that makes sense is that it's always going to start with early position and it's going to have to go through all the players at least once on that round to get the, because it doesn't matter the order, each player has to act preflop regardless of what action they take. So this is the logic that I use to get the positions, because I know that it's always going to start with early position and then it's going to go through the big blind, and I can use the action to add the position to each player. Trying to find, no, it's not this one. Maybe I think I saved on the desktop. Yeah, an example. I realized that is much better. Instead of writing the instead of taking a picture, I can just, not sure why, trippy. So yeah, instead of taking a picture, I can just put a bunch of hands here, copy from the thing, and that way I don't have to, I can just look at a bunch of them. So here's an example. And the way that I verify this is using like later on, once I have the positions, then I verify that the small blind, because I know that this is the big blind and this is the small blind based on the sizes. And so round 0 defines big blind, small blind. So based on that, I could see if the players were correct on the final format of the data. But here, as far as I know, at all the examples I looked at, they start with the early position and then they finish with the big blind. Then obviously you can have more actions, and this is the stuff that I not 100% sure, because I know you can have more actions, and there might be situations where, for whatever reason, one of the situations that I realized is that when nobody bats, everyone folds on the first round, then it might be possible that it doesn't show the big blind. And this is the stuff that I spent some time, because I was printing all over the place to see which player is the one that is missing most often, and usually it was big blind. It was either big blind or early position. So based on that, I did this other thing here, which I add the big blind on the round 0. And I think a lot of the situations where one of the players didn't have position was because of that. Was a hand that nobody bats, and then I think on those hands the big blind doesn't show up on the round 1. So I think this solved that, but I still had some other situations which I still can't figure it out. But as far as I know, I looked a bunch of times, it looks like the other ones are correct, the ones that are working. But I still couldn't figure out why sometimes one of the players doesn't have a position. which is annoying because then it might mean that the other ones are wrong on the thing. So I'm uncertain about this. And it's very difficult to debug, obviously, because I can't like just print the situation that it doesn't work because of the way that I'm constructing all of these things. It happens line by line, so it's not like I can print the hand and then figure out what is the situation where one of the players doesn't have a position. Because at the point that I figure out on this script here that the player doesn't have, then all the other lines are already gone, let's say. So I can't just say, unless I keep a cache or like do some complicated stuff just to print the hand. And then obviously I can print the format of the hand, but then it's just the same thing as looking at the actual final data. So it doesn't change anything. So in this action, I'm looping through the players, all the players, because the players is a list, so I can access directly. I have to loop through all of them. And then I'm only accessing the player that is the current one in the line, in the action line. And then based on that, then I add the round and the action for the player. I append the action for the player, which is the stuff that I was doing already before, but then to figure out what the position is, I use this check here to see if it's the round one. And then I use the lock because I want to determine if there are 6 players or less. If there are 6 players, then their position starts at 1. If there are less than 6 players, then this is the stuff that I spend a lot of time to think about because I wasn't sure if this is the problem, and it might be. But here my logic is if there are less than 6 players, then I want to get the spread to 6, and I want to increase the starting position. Because then the first player track is not going to be there, the position is going to be whatever player it is. So let's say, for example, there are 5 players. The spread is going to be 1, the player position is going to start with 2, and then the first player track is going to be MP. So, because this is 2. So the spread pretty much gets the spread of the amount of players that are left and moves the pointer and up to find the position of the first player. But that's the reason why it's so hard to debug this, because it's gonna depend on the actions here of the first round. And there's no way that I can print only the situation where there might be something wrong with the actions. I have to assume, I'm making the assumption that in the round number 1, all of the actions are going to be, the actions are going to be a sequence of the players here, of the positions. And then after each iteration of this hand here, because each time that it gets to this point, or of one of the actions, is going to increase, is going to hit this point here. So this is getting the information from one of these lines here. It gets the name, the number, and the sum for the action. So after each time that it goes through here, I increase the player position by 1. So that would make it so that even if there are more than 6 actions, more actions than players, then it doesn't matter because the conditions only go up to 6, obviously. And this adds the position to the player. But I think as far as I saw on the data, it works. It's just sometimes, for whatever reason, some of the players don't show up. I think most of the time was because of 0 bats, which is relevant to me anyway, because there's no data you can get if there are no bats, obviously, in the hand. So those hands don't matter. And now what I'm trying to figure out is the reverse engineering the ranges. And this is also another annoying thing because of the data structure that I have to use, because it's gonna get complicated. It's not that it's hard to do, it's just that it's complicated and annoying to deal with. Like first, I don't remember what I did. I tried a bunch of different stuff, like thought about a bunch of different ways to put this, and I used ChatGPT as well to see if it would give me like more clarity on which data structure to choose. And I was thinking about choosing a tree, or if I should be making stuff with tree as well, and not only on this part but on other parts. But in my mind, it didn't make a lot of sense to choose trees, at least for now. I think that it is better to use nested dictionaries instead. So here I was doing a nested dictionary like on this format, but instead of having the string here, I had two different levels, one with the villain position and the other hero position, and the other way switched. It was like this here that I was gonna do, but then I decided to put this string because it's just easier. It's just one less level to deal with. So I'm creating these dictionaries that have the type of the hand, and then it has the position of one of the players against the position of the other player. And the reason why I want to do that is because I want to create one single file for each type of position. And that's where it gets complicated, because I forgot that you have to take into account all the different types of pots, and then you have to take into account all the different types of positions. So for example, I can have a 3-bet pot, but if it's small blind versus big blind, then the ranges are going to be very different than if it is small blind versus button. So each position versus each position is going to change. And also the player that it is on each position changes as well, which is, it gets very massive, like very fast. Because if it's me on the button, for example, and versus someone on the small blind, then I'm gonna have some range on the button, but obviously I don't wanna treat the players that I'm playing against as playing the same range as I am, because then it defeats the point, obviously. So there's two different iterations. One when I'm on the button and they are the small blind, and then the other way around where I'm the small blind and they are the button. And then you have to take into account all the different possible pots and all the different possible positions. And in order to determine this, I had to do a function as well. I'm not really sure if I showed this last time. I think I talked about it, but I didn't show it. So I just created another function to figure out which one it is, which type of pot it is. So I'm just looping over the actions, and then I'm doing pretty much the same thing for the get decisions function. But I decided to move here because then I don't have to think about changing the other one, because the other one is already being used on the other functions. So I decided if it's a raise. Oh, the other thing that I realized is that this was wrong before, and I didn't show this, I think, on the get decisions here. I was making this check because before it was just like this. If current sum is less, or if current sum is equal to previous bet, then it is a call. It was like this, but then I realized that if there is a 3-bet and someone calls, then it's not going to be equal to the previous bet. It's going to be less than the previous bet, because you're just putting the extra amount. And then for that reason, I decided to switch here and to do it like this, because then it takes that into account. But then what I forgot is that before it wasn't like this. It was just like this, I think. So like what that would mean is that it would never reach this endpoint here of the else statement, that it would be a bet, because it's either going to be less or equal, which is going to be considered as a call, or it's going to be greater, which is considered as a bet, as a raise, not a bet. So in this situation, it would never tell me if an action is a bet or not. So that's the reason why I put this. Initially, I was making like this, and previous bets different than 0. But then PyCharm gave a warning here, and then to simplify, and then it did it like this, which I don't understand really well, but it seems like it's the same thing, so I left it like this. I think it's just, it does the true conditions at the same time, but I don't understand how it works. And it's probably because of the importance of operators. Like just like in mathematics, when you have parentheses, you're gonna prioritize whatever is inside of parentheses. Here, I think it prioritizes this condition first, and then it checks this one. It's not checking both at the same time. But the reason why it has to be different than 0 is because if previous bat is equal to 0, then it means that there are no bats in the array yet, which means that it is the first bat. And the only situation where you're gonna have a bat is when there are only checks after the before the bat, which means that this previous 0 is gonna be 0. And if there is a bat before, then it's not gonna be 0, and then it's only possible to have raises because, yeah, I think this is understandable already. So yeah, so I put the same conditions here. If the only difference is that I'm passing if it's a call, but if it's a bat, then if it's a raise, then I'm going to put 3 bat. If it's a bat, I'm only going to put single raise pot. So on the first bat, it becomes single raise pot because it reaches this condition. But then every bat after that, then it increases 3 bat, because then if there's 1 raise, it's going to be a 3 bat. If there's 2 raises, it's a 4 bat, and if there's 3 raises, it's a 5 bat. And then I didn't put more, obviously, because then it's going to be all in already after the 5 bat. So might as well consider everything as a 5 bat. And there are probably not even a lot of hands that reach 5 bat. But then I'm using this function to get and this sets the type, the function. I put the property on the sim builder class of hand type, and it sets the type of the hand. So I'm using the actions one, which is a preflop to set the type. I'm doing all of the other stuff that I was doing on the other script, because even though it's not necessary, I didn't want to think about all the other ways, and I might use this for other things as well. So might as well just put everything there. It doesn't make a lot slower, so it doesn't matter that much. And then here I'm looking through the players, and then I'm checking to see if the player is either me or the one that I'm playing against. And then I get the cards. And then if it's access, this I just put now because maybe I will remove and see later how to change. I think that might be good. But actually, I think I'm gonna think about the algorithm to change to the correct format in the separate from this, and then once I figure that out, I put the algorithm here, because it's obviously better if I save the files already with the correct format. But then if there is XX, it means that there are no pocket cards, so I continue the loop because it doesn't matter. And because the point is to get their cards. For my cards, I'm not really interested, obviously, because it is interesting because there's the stuff that you think you are doing and the stuff that you are actually doing. So that's interesting because it allows you to look into whether or not you are playing the correct frequencies that you think you are playing, and then it allows you to investigate why not. But I think so both are important, and I'm gonna save both, but I'm more curious about the villain's range. So here, if the name is mine, then I access the dictionary that I create on top of the file and put the sim hand type here, which is the current hand type of the hand. And then I create this string to get all the possible combinations of based on the hand. Obviously here is my position versus their position, and then the key is going to be the card and the value is going to be the frequency. So I got the keys to see if the cards are on the dictionary already. If they're not, I initialize them as 1. So I create the key of the cards and the value as 1. And if they are on the dictionary, then I just increase the frequency by 1. And I do the same thing for the villain range. And then here I have to do this other nested for loop here, because I want to change the frequencies to percentages. And this is stuff I'm not 100% sure, but I used ChatGPT to get the formula because I didn't want to think about this. And it told me that it's just the frequency divided by all of the frequency, which I think it makes sense. So you get all the frequency. But this part I didn't think about after I changed the format of the dictionary, so I might have to change now. But here I'm getting all the values for the dictionary, and then I'm summing them. Here is the parts that I have to change, I think. Because here it is gonna be a string. And that is gonna contain villain position and my position. And that's the thing, because here I have to change these loops as well. It's quite annoying to figure out. I think I'm gonna put some music. Probably gonna stay for a long time here today. Let me put a clock to... I'm gonna put, because I talked a lot already, I'm gonna put 1 hour for the clock. And then I'm gonna take a break to eat something and then come back. So here I was getting the items for the thing. So initially I just did a nested for loop based on the positions to get all the combinations. Well, now that I think about it, because now I created this today, these permutations here, so I can use the same loop, I think. Yeah, that's a good idea. Here I'm getting all the permutations, all the possible permutations of this array, to get all the combinations of each position. So what I want to do is get the access all the values of the dictionary that I created, so I can change the frequency of each one. But here, instead of accessing, I think I need to do this loop, and then here I'm accessing each value, and then I just get... Oh, but that's the thing. It's actually, I need to delete this part, I think, because I want to get the values. It's gonna be a lot more simple, I think. A lot simpler. And then this is gonna be our frequency. It's gonna be the sum of this. So this is this line here. And then I update. Trying to think if I can do this all outside. I should probably do it outside of the first loop. And this is the stuff that I don't like, because it's just annoying to think about. It's not that it's hard to do it. It's just the nuances of having to remember the structure of the dictionary. Seeing if I'm getting the information at the correct level. It's very annoying to deal with. And now I have to access this one, I think, because this is the current permutation that it's looking at. And this is the problem, is because I have to access the items to see the values. So I can't do it like this, I think. That's why I did it like this. So here, It's probably better if I, instead of looping through the permutations, I just loop through the items. And just make sure to see if there's true, if the level is correct. So it's the first, then the type, then it's the stuff array. And so the dictionary that I wanna get is not the... It's because each position is gonna have the cards in the frequency, so I wanna get up to this point, I think. So I do need to put there the other information. So I think I'm gonna delete this one, and I'm gonna think about in this. So I have the type, the range, and what is gonna be let me think. I think that's... I'm gonna remove this from here. Just wanna print to see. The problem is that I have to wait all of the code to run to do this. But what is gonna be this thing here? It's gonna be up to this position. So it's gonna be the positions, and then this is gonna be equal to the dictionary. How does this? Of cards and the frequency. So the items of this are the key is gonna be this thing here, which is this, and the item is the value is the dictionary, which is not what I want. And so this is the problem, because then I'm gonna have to do like 2 other loops for this to create the string. And let me get the other loop from the beginning. I'm gonna think about creating the string first. Is that... Yeah, that allows me to get these parts up to this part. And then this is gonna be the dictionary. So, let me think. And this is I think the values of this is gonna be the values of the frequencies. The thing is, it's kind of confusing because I'm not sure if I should do both of them on this iteration. I think I should. And then I update them on another. Yeah, because then I'm gonna have to loop over again. So that's the thing, if I do both of them, then I can't do another loop. Because it would be ideal, I think, to frequency in because that would allow me to get the cards, then I would just update the cards. Or is the other way around probably? No, the card is the key, that's correct. Oh no, but I don't want to update the value of the key. So yeah, the frequency would be equal to all frequency to itself divided by all frequency. But maybe I can do it like this, I just do it twice and just change the value there. Or VLOOM range here. And then also add this here. And then here. Let's Ctrl D to copy the line. Yeah, switch. Yeah, so this part is just updating frequency from int to percentage. And then the problem is I have to do this stuff again here to save the file. I think I do the same loop probably. But then instead of doing these things here, just get the values. Oh, the problem is that this is different because I need the two different positions. I'm just saving the villains one here. And then I will do another loop to save my stuff. And then I'll just change this path here. The other thing I have to see if it's gonna save because I'm creating a different folder. So if it doesn't, then I can just manually create all types of... create the folders of all types of bats for each one, and then the only thing that is gonna change is the name of the file. But I think this one, it might be fine to leave it like this, as long as I'm getting the same range here. So I'm accessing the dictionary that has the current position versus position, which is the villain position versus hero position, and the name of the file is the same. So what I want to do is this file, like this is gonna contain the path of all the possible different hand types and all possible different positions versus each position with the name of the file, and then each one of these files is gonna contain the range of the frequencies of that specific dictionary. So this file at the end is going to be, that's what I want to happen. It's going to be like one hand, for example. Then it's going to have the percentage, which is going to be a number from 0 to 1. And this is going to be obviously for all of the hands. And then I can use this file to open on File Solver to see the hands that they are playing and get to showdown with for each position and each board type. But obviously that's if it works. There might be mistakes that I did here. And the biggest concern I have is not the mistakes that it's gonna crash, obviously, it's the mistakes that it's gonna work everything and then it's gonna be wrong for whatever reason. that I did something wrong and then I didn't realize, and then the data is messed up. And those are the hardest ones and the most dangerous ones, I think. Because then you assume that you did everything right, and then you might take conclusions that are incorrect. But as far as I can think here, I think it looks fine. So this gets all possible combinations, I think, for all the types, and then maybe I should do the other way around, where this one is on top, but I don't think it matters that much, because it's gonna go over all of them anyway. And then I'm looping over this twice. Maybe this is the part that is a problem. I think I should do this loop here instead, because this gets all the permutations, and then I can just do, yeah, current position is gonna be a tuple. So the first element of this tuple has the, so this position is equal to this. This is string here. So position 0 is equal to this. So I can just make the villain position in position 0, then the edge position is equal 1. So this contains all the possible combinations or permutations. Difference between permutations and combinations is that permutations, it takes the reverse order as well. So here you will have big blind and small blind, and then small blind and big blind. So the order matters. In combination, you only have one of the orders. You don't have all possible different orders. So permutation is better for what I'm trying to do here. So I'm getting all the permutations, and I'm zipping through this, and then I get each. So I'm gonna go over all of the different possible positions, I think. And then for each one, I save the file. So I think it looks correct to me, everything. And also it's running now without errors up to this part. So I think that the problem with the position was solved, but it might be because here I'm getting the positions of each player to determine if either one is in position or out of position, and this comes from the other script. So if the players didn't have the position, it would be failing here. And it might be because I'm doing this multi-way check and checking to see if the action is 0 or not. But there might still be a mistake with the positions, I'm not really sure. That's kind of bothering me. So I might look further into it later. But I also think, because I looked into a bunch of examples, and it seems like all of them, the ones that I looked at, I looked into examples that have less than 6 players and have 6 players, and all of them, it seems to be that all of the other positions are correct. The only problem is that in some instances there is one player that doesn't have a position. So I think that the only possible explanation is the problem with the counting there that I'm doing on the main script to parse the hands. The number of actions and the number of players, like for some reason in the last iteration I think it doesn't catch sometimes, depending on which hand it is and what actions have been taken on the hand. So I think it's not a very big problem, because I think it doesn't compromise all the other hands. Yeah, so I think I'm just gonna run this, because now I looked into it a bunch of times and I think that there's nothing that I can see that is wrong here. And probably there is, but I don't know. Hopefully everything is correct, and if it is, then I'm gonna have to think about how to translate the hands into the correct format, the dictionary, if it doesn't work compile. Because the way that the hands are formatted on this thing here is different than the way that they are formatted in Pio, I think. So I'm gonna have to do some string manipulation to get them on the correct format, and it's gonna be very annoying because some of them are lowercase and some are uppercase. So I imagine that I'm gonna have to create all possible combinations of hands based on the string that contains the suits and the ranks, and then based on that create a string format and then parse the hands that I have here into that format, parse the way that this format into the other one. Here it looks like it is not working. So ints and dictionary values. So oh, I didn't get the sum. Maybe I should also print this to see if it is correct. But I think it is. Yeah, I don't see like why it wouldn't be. Because I'm getting all possible permutations and then I'm just accessing the string here. This is the type, so the string, and then this is going to be the dictionary. Up to this point is the dictionary with cards and frequencies. The values are the frequencies, so the sum is the overall frequency. And then I'm looping over the thing. Maybe here I should print this. And then I should print the frequency later. And here I should print a string to make it easier to visualize that this is the point. And then do the same thing here. Let's change a little bit to make it easier to see later. Oh, the other thing that I did as well was create a range, but that didn't work out that well, I think. Let me see. I think it was on this point, this file, because I was getting the batch sizes for each one as well. I was trying to get like a simple way to get the batch sizes without splitting everything into hand types and into different plots. I was just trying to get all the bats without any distinction, just to see if I can get some information to, like, something that I can look into. And the problem is that there was too many different bats, so I created this range here. I pretty much got the delta, which is 10% of variation from the initial bat. And then I create a top range and a lower range, and then I filter to see if it is in the range, the bat is in the range. And then I use this filter to update the bat. If it's not, then I create a new bat and update the original dictionary. And here I did this to get the effective stack size because I wanted to know the amount of stakes that I had there. And if it isn't, then I just if there is something on this, then it means that the bat's within the range that I want. So this is to decrease the amount of variations in the bats, and then I increase the frequency to 1. Maybe I should do like a bigger value here. But the amount of variations that I have in all of the bats makes me think that there might be something wrong. But it might also be because I didn't make a lot of distinctions here. So there's also the problem that depending on which pot it is, the bat is going to be different because the pot size is different as well. So the other thing that I have to do is get the percentage as well. Which I was doing before, but then I decided to not do it and pass the other way. Because I wasn't sure the percentage was correct, because also when I do it with the percentage, it's there's a lot of variations as well. Which I think it wasn't supposed to happen, because I usually bet the same amount for each hand, so the percentage, even though there might be slight variations, the percentages, but it might be because of the other streets as well. But I think I got based on the, I got based on flop here. So maybe, because here I'm reading the other ones, maybe I'll test it out later. After I fix this one, I'll go back to the other one. So it looks like it is working, and it's very small frequencies, so I don't know about that. This is the stuff that I mean that is really hard, because then like it's working, but then I don't know if it is the correct value or not, or if I'm doing something wrong. That's the problem, because it doesn't make a lot of sense, because these frequencies are really small. But it might be because I have the differentiation with the suits, but I still think that it's too small. So maybe the calculation is not correct. So let's see. I forgot all of the frequencies. It's gonna be 100%. And then if I got one of the frequencies, it's gonna be X. I think I should be doing like that. So I have to multiply by 100 and divide by the frequency. And that's the problem here. ChatGPT told me to use this function, so I didn't even... because I wanted to focus on all the other stuff before. Because there were so many problems that I was trying to fix. But this makes a lot more sense. If I multiply by 100, then I think that the frequencies make a lot more sense. And it's probably correct then. Now the only problem is probably going to be the file, where I have to create the things, hopefully. Hopefully that's the only problem. So I multiply the frequency by 100 and divide by the thing. And same thing here. Oh, it's the other way. It's gonna be really interesting to see if it works. Just see the ranges. I think I'm gonna show on stream if it works. I think it doesn't really matter that much. you would be like, the thing that I'm contemplating in my mind is whether or not it's worth it to put in the time, because it might be too hard to finish everything. But it would be really nice to have the, if I can make it work, can make all the algorithms, because then it just automates the process of creating scripts, and then you can train. With Pio 2 you can, there's this feature where you can play against simulations. So it would be like automating the whole process of training based on a specific data set. So you can go on tools and then GTO trainer, and then you can add simulations here. So if it does work, that's what I'm planning to do. But it might be just too difficult to bother. Yeah, it's giving me no such file or directory, so I'm gonna just create it manually. I think all I have to do is put villain and then one for the hero. And then I have to create all different possible types. Single raid spots. Three bats. Four bats. Five bats. Because the problem is that I think that the function only creates files, but it doesn't create folders. If I want to create folders, there's probably other functions, but have to create an algorithm then. Don't want to do that. Yeah, let's test now. I think after this, if it works, then I have to check to create the algorithm to change the format of the strings. And then after I do that, then I can look the ranges in Pio. I can copy the stuff and put can copy all these files and put on the Pio solver. On preflop ranges, I think. So on ranges, I just copy the folder here, and then I can look into the frequencies. So what I'm gonna do is I'm gonna save one range that has suits on the... Yeah, that's the stuff that I think is gonna take a lot of time. I need to create multiple different test ranges of specific inputs, just so I can see the format of each thing. And then I have to do this a bunch of times for a bunch of different things until I'm able to reverse engineer the algorithm that I use to translate this grid here. And it's a multi-dimensional grid because it looks like it is 2 by 2, but actually it has all the suits dimensions. So each square has 4 dimensions. And that's why it's very hard. So it's not like you're translating like a two-dimensional grid into a dictionary or the other way around. And also the order matters, I think, because if I'm gonna create the simulations, it has in the format it has to be on this format here. So the order of each one comes first, I think it matters. That's the problem. Oh, actually, it's gonna defeat the purpose if I just put all of them the same. Okay, so now, yeah. So that's the thing. Maybe it doesn't matter the order, because here it's just including them. Maybe it doesn't matter. But my concern is that it doesn't matter here, but then it doesn't matter when it translates into the other one. That's the biggest issue. Because then how I'm gonna figure out the algorithm to translate the dictionary into the grid. because then it gets really annoying, because then I'm gonna have to build the simulation series, look at this output, and then from this output, like I create a specific range here, then create the output, then from the output get the values, and then from the values I create the connection between the inputs that I'm putting here and the position of each square, until I'm able to get enough of them to create an algorithm that translates one into the other in the correct way. Nice. It worked. Let me see if there's values actually here. Oh, but it's doing like this. Oh, maybe it did work because it's... Oh, but no, it doesn't make sense. I think something was wrong. Because this is supposed to be... So I think it's not updating the values. That's probably... Like this doesn't change the values. I need to access from this point, I think. Because I need to change it on the dictionary, but I'm not really sure if it's gonna work. Or it's the other way around, actually. Yeah, I think this way is gonna change. But the great thing is that it's working at least. So now I have to think about how I'm gonna translate. Well, first, let me think. The other thing is whether or not I should write this on a text file. The reason why I wrote it in JSON, and I think I'm gonna do it in JSON again, is so that I can open this and on a different file and create a script to translate each key, to update the keys for the correct format. Maybe I should do another thing here as well and then save to text just to check. Because if it works like this, then obviously I don't want to bother creating the script that translates. And the only difference here is the text extension. Yeah, so the question and the challenge with this is that this doesn't give me any new outputs if I just... Maybe it's easier if I do like this. If I just write stuff here, or if I put... It doesn't give me anything. You know, it only gives me extra stuff when I click on build, extra commands. So I have to click on build each time and it doesn't show the full line. Well, let's see here if I change... And this is the auto position, so it's starting with 0, 0, and 0.5. And 0. It seems like it's random. I'm gonna put only aces here, and then only 2 here. And then I'm gonna build it like this. Show ranges. And now is everything 0. The lines are also gonna be really annoying to figure out. I'm gonna do this. Oh, this is the point. Yeah, so it's saying position, so it starts off with 2, 2, 2, I think. Because here is 1, 1, 1. 1, 2, 3. There's 6 ones. 3, 4, 5, 6. That's because of the combos of 2. Let's put 50% and then try again. And the problem is that I think there is a way to save this stuff on a text file as well. That's another thing I can do, now that I think about it. Yeah, I have to think if there's a better way to translate this stuff. Because the only way I can think is doing multiple different inputs. If I can save to the text file, is even better, because then I just save everything, like I create the input, save to a text file, and then I can create a script that translates the paths of these files here into the ranges here. So it gets these files and then outputs the other ones. Maybe it's not that hard actually to create an algorithm that figures it out. Basically I have 2 different patterns. I think that maybe I can use some like machine learning algorithm to do that. Because gradient descent seems like it would work for this. It's some sort of decision tree thing. Because I have the input on one side, which is this matrix of zeros and ones. It's 0 to 1. And on the other I have the dictionary, so I can... And the question is, how do you figure out which column is which thing? I think that this is a 2 by 2 matrix, but instead of having just the cards, it has the cards and the suits for each thing. So that's how it works. And then the question is, how do you figure out the correct position of each one? I think. Change this music. This okay. Yeah, there we go. Nice. Interesting. So now let me look if Pio, if it's gonna work on Pio with this format. It doesn't work, huh? Not a proper range item. Yeah, so I'm gonna have to transform get a different format. Let's see this one. Oh, this is what I was gonna do. I was gonna save one that has the different suits. And do a random one. Yeah, so that's the thing, when the frequency is 1, is only the card as well. Let me modify this and see if it works. Just put one there because then it's easier to translate in the end. The other thing is that it doesn't have the dictionary here. So let me think about this. Yeah, I have to transform the stuff into a string. And then I just put the patterns. So I'm probably gonna create a different function. I think I'm gonna do this on another file so I don't have to run the whole code again, but then once I figure the function out, I go back to the previous file and then I put the function there to write the file in the correct format each time. So it does work. Yeah, so let me see as well. What makes it difficult is the suit cards, because they are letters as well. The other ones I can just put lower and then it's gonna decrease the... It's gonna make a lowercase the suit card. Well, maybe I can... Let's see if it works. Maybe just the dictionary format. Oh, so it does work? Oh, let me add a different one. So... so it doesn't matter. So it's gonna be easier than I thought, I think. Space, window down. I think it is working. Let's put 9. Yeah, nice. So I think it's gonna be easier than I thought. Let's see the difference. So the only thing I have to do is just join them based on the space. Split and join. And then add them on the string. I'm gonna use ChatGPT just so I don't have to write a bunch of times in case I mess it up. Let me see if there's anything. Yeah, I think after I split, then I just loop over the dictionary. And then I just add to the string with the correct format. I think this is what I was doing here already. I was asking here. I was thinking about changing the suits as well. Also, it's better to ask in Python as well. I think that this is all that... There's nothing I need to do more. Let's see. I think since the letters of the suits are all different than the letters of the cards, it doesn't matter which one is lowercase and which one is uppercase. Just trying to think if I miss any card. There's ace, diamonds, hearts. spades, ace, diamonds, hearts, spades. Oh. And string replace. So this is better, I think. So here I'm gonna loop over. Let me think about this. Yeah, the thing is, I'm not sure if he's gonna... It doesn't matter actually. I was gonna say I should update the dictionary, but it doesn't matter because I'm gonna create a different string. Then what is gonna be the format of the string? I have to do this first here. I'm just gonna differentiate. And then here. Actually, I think if it is right there, I think it's better. Yeah, so it's the thing and then just the frequency, the card and the frequency, card frequency, and then I just dump this stuff. Yeah, I think unless I'm missing something, I think it's correct. I'm gonna print there so I know if there's a mistake. Maybe I should print the formatted. Oh, actually, I need to put a comma here, I think. Because we're gonna add them all together. Yeah. Let's see if it works. Then after this, I think it becomes the hard part if this works. Which is to build... Actually, I'm gonna have to also another hard part, which is gonna be to get the bat frequencies. That's gonna be really annoying. And then even harder is gonna be to build the simulation based on the commands. I think I'm gonna try to build the simulation first though, using arbitrary bat sizes, just with the ranges that I have. It looks like this is wrong. So and it's not working. Oh, it did work. Yeah, but I don't understand here it stopped here as well. I think there's something wrong with this. The format is correct. Oh, what's wrong with this? Here also shows the string here in the beginning and after it doesn't. It doesn't work. It's weird because it doesn't show anything either. See if I change this, is it gonna work? Nope. Let me erase some at the end here, this part. I don't understand why this... It's probably because the way that I'm writing there. I'm gonna use ChatGPT to see a better way to... I think I'm just gonna put the data structures for ChatGPT and ask how to format it in a way that is gonna work on the file, the text file. Not really sure if this is the problem as well, or if something else. The thing is, I think they all have to be... Like, there can't be any indentation. They all have to be connected, I think. And this might be the reason. But it should work because technically if I want to put different frequencies for each one, I think I can do that for each card and each suit. So I don't see why it has to work. The only reason would be for the file format is wrong. The string format here is wrong. Oh, there's this the end here. Maybe that was the problem. No, it doesn't work. So what else? Maybe I should erase a bunch of them and then see if it's gonna work, if there's only a few. I'm gonna test with the indentation and without the indentation as well. I'll test like this first. Doesn't work. Oh, let me see. So now let's do it like this. It might be because of the format of the string. Yeah, it doesn't work, so it's probably the format. Oh, maybe it's the then here, because it's D on the solver, I think. Yeah, T. So that's one thing that I have to change. Let's see if that solved the issue. It might be that, and it might be the lowercase thing. Then in some of them works, and others it doesn't. I think a simple way is just to create two different strings and then just check to see if the letter is. Oh, but then, yeah, I have to split. You split into a list and then loop over the list and then check to see if the letter is or not on the ranks. If it is, a decrease to lowercase. Oh, now it worked. So it's the 10 thing. So I have to switch the 10s. So it could be that, and it could be the other. I'm gonna see if the indentation works now. If I do it like this, if it's gonna work. So it does work. So the problem was the 10. And also it can be the string. So I'm gonna ask how to write a string to a text file in Python without adding the string symbols. Maybe I should create a simple algorithm that I can just use ChatGPT and get the correct format. It might be better. But it may also create more problems, because it might work now and then for whatever reason another time it fails. So it adds more complexity, which increases the probability that something is going to be wrong. So yeah, I think I'll just change the 10 thing for now, and then in the future, if I have problems, then I'll change again. Or even now, if it doesn't work, I'll change again. So here I'm gonna check to see if 10 is in the... Yeah, I think it's on the cards. It's probably before. This is better. I think splitting is probably better than using replace then. Because if I split, then I can access each element and then replace. I think I'm gonna use ChatGPT. It's probably gonna come up with something that is more efficient than I am. So I want to change this string here. Oh, actually, yeah. So change this to this. I think I'm gonna grab something to eat, be right back, and then I'm probably gonna watch something while I eat. Or read the Ethereum book. I think I'm gonna read this book. I'll think about something to watch. Maybe something related to stuff that I'm doing now. I'll search for something about matrix, how to change matrices. Use AI to change. I think convolution has a lot to do with this as well. Because convolution is just a... Actually, convolution is very similar because it's a matrix of colors. So each square of the matrix has an RGB. So it's actually a very similar thing, I think. Maybe using a convolutional neural network to get the... to learn or to fit the data that I create manually. But the problem is that it's not a lot of data, so... Yeah, but I'll watch something related to this, I think. I'm gonna go grab something to eat, I'll be right back. Yeah, so I think when I watch something about convolutional neural networks, I'm probably not going to do that. I think I had a better idea. I'm going to try to see if I can automate the process of saving the trees. And if I can, then I can do, like, I can get the size of the matrix of the bats, the set ranging position thing, the size of this stuff here, create a string with the size of this, and then create another string with all possible combinations of cards, and then I can create an algorithm that creates multiple different variations of this string here, and then like do something like that. It is very similar, I think, to machine learning, because I have to create two different sure if data is the right word. I have two different strings, and then I'm changing the inputs of one string to create the other one, and I want to create something that learns over time what is the correct relationship between them. So it is like a classification neural network, I think, to do something like that. But obviously I don't want to overcomplicate this, so if it doesn't require to do something like that, then I don't do it. But if it does, then it might be a possible alternative to, because then I can actually I don't need to save the things. For the ranges, I think I don't need to save, but then for the bats, I think I'm gonna have to save, because the amount of lines depends. Or maybe it's always a fixed amount of lines. The only thing that changes is the numbers here. Well, it's gonna change depending on how many bats you have for each street as well. But let's say I decide to put a fixed amount, which I think I'm gonna do. So the ideal, I think, would be to put 3 bats on each one. Like, even that's a lot, is too much. But just for experimenting, I think is good. 3 sizes for each street. Put the limit, and then I variate only the values, and the amount of lines is probably going to be the same. So if I could automate the process of creating these lines here, which I got it from this file here that I saved, then what I can do is just create a bunch of different possible create an algorithm that creates a bunch of different possible combinations, get the commands from the file, and then use those commands to map to the bats. So each time that I create a bat sample, I have the output through the algorithm. Like, I pass in a bat, all the arrays with the possible bats, and in the structure that I have there on the simulation. And then based on that, I see the output that it gets here, that it gives me here. And then I generate a bunch of this until I have something that allows me to know, like, or I can just brute force. I don't need to know exactly what lines are, because I can just get all the possible bat sizes that I want. Yeah, if I can do that, then obviously I could do it. So if I could figure out how to save, then I don't need to figure out how to do the lines, because I can just create the string with the file, and then I could just save the file and run from the file. Or I can also use the commands, but then I already have the file, so I can just read the file line by line, and then each line is going to be a command, and I put this on a loop until the file is read. So it might be easier than I thought, actually, this way. The only downside is then I would have to... Yeah, but maybe I don't even need to save the file. I just need to get the bats and the output. I create something that gets a bat and then creates the lines here. And if I create a bunch of different variations, then let's say I put 30, so I put a bat 30 here, but the sample size, the data set has like 33%. Then I can just use the range thing that I created to calculate the range, and then I make a condition that if it is 33% or if it is within that range, then I change the bet to be 30 instead. And because I already have the lines for 30, I can just do it once and then I simplify. But the biggest uncertainty that I have here still is that when I do the simple bets here, it shows a bunch of different bets. So I'm not really sure if it is correct. So I'm gonna have to see this. But I think I'll think about this after I make sure that the ranges work. So I'm gonna watch some video while I eat, and then I'll do that. I think I'll do evolutional. I'm thinking about if there's something more specific that I can watch about translating the matrix into the other one. It's probably going to be convolutional because it's pretty much the same thing, I think. It's actually the same problem, but in a different setting, I think. Because you're updating, it's like updating the pixels based on the values. It's actually the same thing. This is interesting because it makes me think about the connection of poker and everything else, about finding the Nash equilibrium in poker. So the textures of ranges in poker are like textures of pixels, of colors in matrices. So finding the Nash equilibrium is finding the correct frequency of distributions of decisions inside of the matrix. It's a very interesting thing to think about. It's actually exactly the same thing. When you're playing poker, what you're finding is the correct frequency of distributions inside of a matrix. So there's this connection between space-time and the Nash equilibrium of the matrix that determines the distribution of ranges. So the geometry of, like and I always made, I think, this connection subconsciously, because when I was thinking about other things, I was thinking about this stuff about poker. But the way that I think about poker is that the structure of truths and lies is a geometrical object, and the geometrical object is the range itself, and the range is the distribution of frequencies. And that's why I think that lies are always relative to truths, because it's a geometrical object. It's like a poker range is one of these matrices here. So when the bets is better to see because you have the splitting decisions for each cell of the matrix. And the reason why they vary is based on the context, which is the position of the players and the equity they have in relationship to the board. So the board is the context, like is space-time. And then the relationship between the players determines, the context of the space-time determines the Nash equilibrium, which is the balance of truths and lies. So it's kind of like updating the electromagnetic field in relationship to space-time based on a certain frequency. And then you get at Nash equilibrium, which is always relativistic because the frequencies are always relative. So the Nash equilibrium doesn't exist because it always depends on the context. So you can only get local optima of Nash equilibriums because you're calculating the frequencies based on the current setting. But because there is an infinite amount of bets or infinite amount in poker, there isn't an infinite amount of context because the cards are limited, obviously, and the rules are limited. But in space-time, I think there's a limitless amount of context because you can always have different situations. So it becomes even harder to find the Nash equilibrium, which is the right frequency of the distributions. But it's very interesting to think about that the convolutional problem is pretty much exactly the same thing, I think, as the poker problem. So training in neural net to find the classification of what is a cat, for example, in a picture, is exactly the same thing as finding the Nash equilibrium in a range in poker. The only thing that changes is the context. It's very interesting to think about this.
Hey everyone, welcome to the semicolon. In this tutorial, we'll be implementing a convolutional neural network using Keras with TensorFlow as backend. We'll use the MNIST handwritten digit dataset to build a digit classifier. If you do not know what a convolutional neural network is or have any questions in the functioning of it, watch the video about working of convolutional neural network, and that should give you a basic idea of convolutional neural network, and then we can start. So this channel also has lots of videos on machine learning, and you might want to subscribe for that because I have new videos coming up. So let's get started with implementation. We had run random forest algorithm on the same dataset, and that gave us around 96% accuracy. So let's see what convolutional neural networks offer us here. I import the libraries sequential model from Keras models. Also, we need to import dense, dropout, activation, and flatten from Keras layers. I'll explain you what each of them mean as we use them. For the convolutional layer, let's also import convolution 2D, and for max pooling layer, let's import max pooling 2D. So to validate our model, we'll be needing test train split. So I'll be using the one from the scikit-learn because I'm very comfortable in it. Otherwise, Keras has a utility to do the same function. We need to import pandas and numpy as well. The data is available in CSV and I'll import it using pandas. So this is our data, this is what it looks like, and we'll have to modify it a bit to be able to feed it into our connects. So for now, all the pixels are arranged as rows, and we need an image to be represented as a matrix to work on it. So let's reshape the image, the array, using the reshape function. So I reshape it to 28 cross 28 cross 1, and 28 is height, 28 is width, and 1 represents channel. In the RGB color images, we can have 28 plus 28 cross 3, but we have black and white images here, so it's 28 cross 28 cross 1. So I create two lists. One is to store the images and the other one is to store the labels. Say if the first element of df underscore x contains the pixel array for image representing say number 4, then the first element of y would contain 4. So that is why we have two lists, one to store the pixel arrays and other to store the labels. So now let me go ahead and pull all the pixels into the list, converting them into arrays. And let's store the labels too. Now the problem we are looking here is classification problem, because we have the digits and we have to classify them into 10 classes, 1 to 10, 0 to 9 actually. So we need our labels or results to be categorical. Currently they are represented as 1, 2, 3 and so on, and this is a problem for us. And why is it a problem? Because firstly, labels 1, 2, 3 and so on signify a relationship. Say 2 times 1 is 2. So which is not something we want our model to infer. And we are only interested in identifying the digits in this problem. And we know that it can only be recognized by its shape. So shape of 1 representing value 1 is independent of shape of 2 representing value 2. So that is why we don't need any relationship among themselves, and that is why we have to make it categorical. And how does making it categorical solve the problem? So when we make it categorical, we make different columns for each digit, and then the digits which is the label would have value 1 and all other digits would have value 0. So for example, 0 will have vector 1 and 9 zeros, and 1 will have 0, 1 and then 8 zeros following it. So that is how these vectors are orthogonal and they have no relationship among themselves. So Keras has a two categorical function which takes in our labels and the number of classes and transform it to categorical labels. And once we are done, let's convert everything to the NumPy arrays and check the shape. And the shapes are good. Then we split into test and train, and we're done with pre-processing our data for feeding it into CNNs or convolutional neural network. Now let's start implementing the main part, which is our model. Let's start implementing our convolutional neural network model using Keras. And we need a sequential model, so we start a sequential model by typing model equal to sequential. And before we add any layer, let's define our architecture first. We'll then need to test it out and make
I forgot to change the screen. Right. Write the strange text file in Python. Single quotes or triple quotes. Huh. I didn't know there is this difference. Oh, but I am using single quotes here. So maybe this is just ChatGPT making a mistake. I'm gonna put one more hour and then I'm gonna take a break after that. Let's try 3. Maybe it will work. 3. I can just use replace probably. Oh, the issue is that I have to see. I'm thinking here because it's probably better. I wanna ask in a generic way to replace all the towns, not just in specific case. And this is a specific case. I probably would do like this, and then put the condition here. As that's, maybe I can just split. Scar that splits by town, and then see where. But I think this is not gonna work. Yeah, that's what I was thinking about. Yeah, hopefully now it will work. I think I can also strip here. I think it's art trim. Trim. Oh yeah, art's right strip. It's gonna remove the comma at the end. And just to make sure. It's probably our strip. Yeah. I don't understand why it doesn't print the string. And now he's replaced, but he still has the string here. Oh, maybe it's because I'm using JSON. That's the thing. Yeah, I should just pass the string directly, I think. Let's see if this works. What I'm gonna do after this. So if the ranges work. Then it's either the bats or figuring out how to translate the ranges into zeros and ones there. Into the matrix that in the other format here. I think I need to figure this out first. Because it's better if I have the outlines of bats. Yeah, but maybe it is better to get at least an idea of the bat sizes that are used, so I can create a template based on them. And then I can figure out how to build this. Obviously the board is the easy part, effective stack is easy as well. And the pots is easy. The hard part is the lines and the ranges. And then after building I have to see on the documentation how to run as well and how to save. And after saving, then it also might be really hard to create the node locks. Like, it's hard for me to think about like, what exactly I wanted to accomplish in the beginning. But I have to think about what I exactly want out of this. And what I want is to see in my own game and in the players that are playing against what are the mistakes they are making in the simulations. So ideally I want to create a simulation that exploits their imbalances. But that's where it gets hard, and I don't know if it is possible just with this data here, because I think what I would have to do is to get all the frequencies that they get to the river at with each card, but then the problem is that I'm only seeing the times that they get there. Where exactly do I node lock on the simulation? That's the thing. Because if I don't know the times they don't get there, then I can't see the imbalance in the frequency, I think. The only thing that I can see is imbalancing the variety of bat sizes. Because obviously, if I put more bat sizes in the simulation, that the ones that people usually use, and then I can unlock the simulation to only use those bat sizes, and that's probably gonna show a lot of imbalances. But besides that, if I only use the bat sizes that they use, the only thing that I can change is the only thing that I can do is node lock the frequencies. So I need either you can't do it, or you need the sample size with all the cards shown, which I know that Bulldog they allow you to see, but I don't know. I think my sample size doesn't have it. The whole cards. I don't know for sure. I think it's possible that I had the one with the whole cards, but then it's either on the external hard drive or I lost it. I think it's very likely that it's on the external hard drive. I'm trying to think if there's any other way that I can no lock simulations to show the exploits. Based on the data, obviously. What else can I do? Oh, the other one obviously is the ranges. The pre-flop ranges. I think that alone already helps a lot, because if you know their ranges, then, or if you have a good idea, then then you can create simulations based on that. And then the Nash equilibriums are more accurate in post-flop. Because this is one of the big challenges in poker, is that since the game is not solved, pre-flop is the hardest tree to solve because it has more nested compounded decisions later. So if you assume that the players you're playing against are playing different hands pre-flop, then all the simulations you calculate after are gonna be wrong, with the wrong equilibrium. And this is the part that I think is the most subjective, I think, for most people. Where most people have different ranges for the same positions because of different styles of play. Nice, it worked. Let's see if it works there. Hopefully this works. No, it doesn't work. Damn. So what else can be wrong here? I think it's maybe the final outputs there. And it's also not removing the last comma here, which is weird. Maybe it's not adding the whole thing. I think I'm just gonna test it like this. What else can be wrong here? The only thing I can think is the suits. see if like this works. Still doesn't work. Maybe it's because I had the other files open there. Let's see the comparison here. I don't get it. It's probably one of the patterns or the way that it is written. I think I'm gonna have to format exactly like this here, with the lowercase and uppercase, which is very annoying. So the format here is rank. Oh, it's a rank suits rank suits. The suits lowercase. Here as suits, then rank. And suits, then rank. So it's probably because of the way that I'm adding this is adding the other way around. So I think I have to reverse the string. I think the best way to do it is to separate everything into an array and then add to another list. And just decrease the ranks. Because if I separate, then I know at which index are going to be the suits and which index are going to be the ranks. And I can just make lowercase the suits. So I do this stuff that I did already, and then I split. And then I also have to reverse, so. I want to keep this on the other screen, so I know the format. So at this point here, replace I think it's better if I just do this on another file so I don't have to run everything. I can just run a bunch of times and then test. Actually, let me copy this one. Now it should be the same. So I think here I split this. On the print. Yeah, how do I split all the thing? I think maybe looping is better. I can just loop, I don't need to. The problem is that actually strings are immutable, but then it doesn't matter because I can just lower. And sprints the character. Yeah, but then I can use index in the array. I can do based on odd or even number to put lowercase, but I think it's easier to just put the exact indexes that I want. Oh, actually, that's the issue because I need to reverse. So maybe I reverse the string first. I think if I do like this, it reverses, but I'm not really sure. So I'm gonna ask ChatGPT. Yeah, there we go. So I loop through the reverse format of the string, which is going to be the format that I want. So if it's first going to be rank, then suit. So rank, suit, so so rank, suit, rank, suit. That's correct, I think. Yeah, I think that's it. And then I obviously I do the same thing for the other one. Oh, I need to add here as well. And then I did the same thing for the other case here. Oh, actually, yeah, this was here. Yeah, let's see. I think this is correct. Thinking whether or not I should put the exact ones that I have there, but I think it doesn't matter. I don't think it's worth. I can just look one by one and see. Oh, but here is the other way around, actually. So it's supposed to be Jack and then spades. And clubs, then... Yeah, so it's the other way around. If I do like this... the problem is I have to switch the order that I add them to the string. I think. Maybe I should put one that is exactly the same, so it's easier to think about it. It's hearts, then it's shoe. Here would be this one is easier. Diamonds. Then clubs. Yeah, so I need to go from this to this. So reverse the order of the A's and D's there. What is the best way to do this? And maybe it is easier before I split them here, or replace the space. Let's see. And then I get the reverse of this, of each one. And then I lower. If I do it like this, then I think I can just erase this and then take a different name here. Let's put element then, think about it later. I think about the names later. Let's see. Maybe it doesn't matter if I do this as well. And so it's not working. So this does work. Oh, I guess it's because I'm just decreasing the... I'm just getting one character there. So how do I decrease only the second one? Let's ask ChatGPT. Yeah, it's just the index probably. So that's probably the easiest way. Yeah, there we go. Nice. I think this is correct format now. And then I do the same stuff on the other one. Nice, I think now it's correct. I'm still not sure about the frequencies here, if they are correct or not, but it's gonna be easy to see once I have the whole range, if it makes sense or not. I'm only gonna copy this part actually. Oh, fuck. has to be from here. Yeah, I think this is correct now. Should be the same format. Oh, so maybe it's because it is a string and not a JSON object anymore. That's why it's giving me an error there. It's not because of the format, I think. It's string. Because I have to do the JSON dump thing. The problem is that if I do the JSON dump, it's gonna put the string symbol in the beginning. It's complaining about the string symbol. Also, maybe it's just the string symbol that's... No, but then it complains that it's not a proper, even if when there is no... Oh, D6X, that's the problem. So there one of them that is incorrect. But it's weird, so it's probably... this can be a massive issue because it's probably the way that the pocket cards are... I'm getting the pocket cards, and like, it could be a mistake in the beginning of the script. It's gonna be really annoying to figure out. Yeah, so here is the issue. And this can be a massive problem because it might be a problem with like all the other stuff. So it's a situation where I'm not getting both of the cards. Like here. The cards object. Or a string. I think I'll just print here to see what it is and put a condition that should not put that card there. I'll print first and then I want to fail so I can see what it is. Maybe it will give me insight on what can be wrong. As the way that I'm getting this is from the beginning there. On this thing here. Yeah, here. So it can be a problem here or a problem in the file that has the hands. I don't see why it would be a problem here, because then I think it would have a lot more mistakes, and this doesn't look like it is incorrect. I don't understand what it's printing here. Frequency. And it's printing the route. Oh, maybe it's because it's not replacing the 10 there, so there's 3 characters instead of 2. It's actually easier to print the current card instead of the reverse one. But it's also interesting that here it's printing 10 here. Oh, I'm doing... that's the problem. I should split the cards T here. Now let me run this again. But it's probably an issue that for whatever reason is not catching the 10 on the string. And put some other music. Yeah, CAX. It's interesting. So, oh, maybe. Yeah, but I'm not really sure if it is possible for players to show only one card. Yeah, I think it's something weird with the actual text file that I'm parsing. Because in some hands only one card is showing, and then it's gonna be one card and then an X on the pocket cards. So I have to put it on here. I just put it like this, and then it's gonna solve probably. But I'm trying to think what situation... Like, I can't think of a reason for why this would be wrong, so I think this is correct. So I think it's just the nature of the text file that I got. And I don't understand why it would be like that, though. Other thing that I thought about is that I can just open Holder Manager, and I can also play around with Holder Manager to see, because the hands that I'm getting are in the format of the Holder Manager hands. So I can just open Holder Manager and I can test around to see if to get different informations, to see, for example, what the type of the action means, because that would probably make it a lot easier as well to figure out not only the positions of the players, but to separate different types of bats. I think this is one of the reasons why it is so hard, is because I'm missing a lot of information. I think it would actually be a lot easier to build either Hold'em Manager or something like this than to do what I'm doing here, because like if you have all the information, then I think it's easier to build it, the trees. But what makes this so difficult is that I have to parse line by line and then translate the data structure. I think that makes harder. But obviously it probably was very hard to build all of this stuff. I have a lot of respect for the people that build this. Let me test with this, and I think it should work probably. And I don't think I'm gonna put this on a try accept, because if it's wrong, then obviously I want to break, because otherwise the range is not gonna work there. But here, yeah, here I think that was the problem. I think it wasn't even the format, it was just that there were some hands that had this axe, and then it doesn't work. But now, obviously, I'm gonna leave it like this, because it's a lot better. I think I might stop next break. The next thing that I want to do after this, if this works, is to figure out the bats, I think. So this script here. I think I'm only gonna get the simple bats first. Yeah, I get this one first, which are the simple version of bats without any classification of single spots or anything like that. So I get the most frequent ones. Here I'm already sorting based on the frequency. So I got the ones that have the highest frequency, and I build the simulations based on, like I build a simple template based on those bat sizes here. And then I try to do the whole thing where I put a bunch of different inputs here. Then I get these text files. I save the inputs, then get the text file that have the commands. And then I try to create a script that learns the connection between the inputs and the outputs here. And that way then I'm going to be able to automate the process of building the tree. Or I can just make the simulations based on a standard sizing, based on the sample as well. And then just do the simulations based on on the different flops, and then change the starting point and effective sizes only, which would be easier to do because I already have that on the first script that I wrote on the analysis here. It already gets the starting point and effective stack, and then I would need to get the boards only, and then yeah. Then since I would have the templates of the bats, then I wouldn't even need to worry about that. I can just run up to the preflop, which is round 1, get all the initial information, then place the template of the bat sizes and the raises, and then create the simulation based on that. Oh, and the ranges, then I can create an algorithm that is going to search for, in the tree structure here that I have, that is going to search for which position it is. I got the position of the villain, my position, then searches for the range on the text file on one of these folders here, and then uses that to set the ranges. And so I need to create an algorithm first that is gonna translate the text file of the range in the dictionary format into this format here. I think that's the first thing that I would need to do. And then after that, I think this one is probably easier to just do the stuff that I'm talking about now, which is simplify the bat sizes and then just get a standard string, and then I can put on one string only and just do one command. that has all the bets, and I use all the same ones for all the simulations. But the ranges I need to figure out because there's too many of them, and they're gonna change all the time based on the type of the hands and the positions of the players. Yep, actually, it might be easier than I thought it would be, so I might be able to finish this. I was thinking about whether or not I would finish this because I thought that it would be a lot harder. But I guess I did most of the work like without realizing. Because I thought that after this stuff I would have to think about a lot more other things to structure the simulation, but I think I was thinking about everything at the same time, so oh, I forgot to add there. What's going on actually? So did I... Oh, I'm not changing the thing. It's what should be final format here. Yeah, so let's run again. I think I might create different folders as well to keep everything. The only reason why I didn't do that yet is because I know that if I create different folders, it's gonna require relative imports on some of them, and it's gonna be really annoying to run the files. So what I might have to do then is create another file to run from the top of the project and import everything else, and then change that file all the time that I wanna run a different script. And I don't wanna do that now, so I think I'm gonna save that for... Once all of this stuff figure out, then I changed everything. I put everything on specific folders for what they are for, then change to relative imports. Yeah, there we go. Let's see if this works. Actually, and still not removing the... I'm gonna leave the comment just to see if it works like that. I don't understand why it's not removing the comment from the end there. I'm using Artstrip. But I guess I'm gonna use the other slice technique that ChatGPT showed. There we go. Nice. So it works. It is obviously weird because the frequencies are messed up. There's no way that... Like, people are not only opening this... I guess the reason why the frequencies are like this is because the amount of hands... Yeah, let me think about this. Yeah, it's probably because the amount of hands. Because there's the correlation between... Yeah, but it shouldn't matter because it's related to the sample size, right? So I increase one time. Now let me think about this. Yeah, because it's a percentage of what times each player plays the hand in relationship to all the other hands. is not a good representation of how. But I guess it doesn't matter because the thing is, I'm trying to capture the percentages in relationship to the other hands. Let me think. Yeah, everything represents the frequency that all of them were played. And then I'm getting a percentage of that. This makes sense or not? It is very interesting though. Like even if the percentages are not accurate, because it can give you an idea of how people play. Like what hands they're playing in which proportion. So let me think. I know you can scale here. But it still feels like it's not correct here for some reason. I think that... yeah, there's something weird about this. I think that the proportions of each one are correct. That's the thing. Like, the percentages of each one in relationship to the other one are correct. But I think that the value here doesn't represent the frequency, if that makes sense. So if you could scale, like, this should be for the highest value here on this bit 1, and the other ones should be to increase by the same proportion, then I think would be a better representation. I think that's the thing. So what I probably need to do is divide this stuff by 1. Yeah, this doesn't make sense because... actually, it might make sense, actually. Because this is single raise spot. So... and it's saying that aces are almost never played as a single raise spot. Yeah, villain single raise spot is big blind versus button. So I think this is when they play on the big blind and I play on the button. But it's weird here because like these hands should be played a lot more frequently. Like some of these hands, like Queen 7, should be pretty much always 100%, I think. Most people are gonna play Queen 7 or Queen 8 suited, for example. Jack 8 suited. And yeah, like some percentage of the time, a lot of people are gonna 3-bet these hands, but like it still wouldn't be around 13 or 15%. It would be closer to 1, I think. So I think I just need to spend some time figuring out what's the correct way to calculate. Like what is... because I can define really well what do I want to get here. Because what I'm getting here is the frequency of each hand in relationship to all the hands that were played in the sample size. So is the amount of time each hand is played in relationship to the other hands. In relationship to what pot it is. And I have to... I want both to scale this to be more representative of what the range would be in an actual simulation. Like with the size, with the frequencies scaled. So that is a more accurate Nash equilibrium later. But at the same time, I want to find ways to change the the value, so it allows me to see if there's a high probability that I can trust the result here, because there might be something that I'm missing along the whole process of parsing all this information that might be giving me the wrong results for what hands they are playing. And the other thing that could be the problem is that the sample size that I have is not very big, because even though I have a lot of hands, out of all of the hands, it's a much smaller the percentage of hands that I actually played, and that is not multi-way also, and that it gets to the flop, it gets to showdown. So that's the thing. Like, these are the frequencies that show in the river. That's the thing. So I think it might make sense actually, because if you think about it, it might be the case that most people play, for example, Jack 8 suited, but then it's only gonna get to the river a very small frequency. And usually that's what happens as well when you're studying simulations. Like, the frequencies in the river are way smaller, because it's like the trees branching off into smaller and smaller subsets. So this would be the combination of the hands they get to the river with, I think. Big blind versus button, single raise pot. So the question is, how do I make this frequency represent? And this, I think, that's the problem, because it's kind of impossible to do that, I think, if I don't have the showdown. It would be how to make this represent what are the actual frequencies in the flop, on the flop. But I think what I can do is just scale this. Like, I can scale in the same proportion, in the same way that this stuff here, like normalize, rescale, max range 1. I can just do this. Even this is not enough though. I want something more like this. But I guess I could just do that. The concern that I have with doing that in the script here is that then it might fuck up for other, where there's like a better distribution, let's say, because then the ones that are broken down are gonna become 1. So if I have a hand, for example, that is played at 0.8 frequency, then if I multiply by 4, I lose a lot of accuracy. But I think it's not that relevant, because it's not going to be that much of a difference. As long as there's a decent representation of the proportions, I think that's what matters. And you can see here that it's actually very interesting. Because this allows me to see, like, it's like seeing what hands they get to the river with. And I think I'm not gonna show the other ones, obviously, because it's very valuable. And maybe I can get more data to see this as well. But I just need to clarify, like, or think about different ways that I can calculate the frequency there, so that it might be a better, it might give me more information here. Because I want to use those ranges to build the simulations, so. And then after this, I'm gonna focus on the bats here, I think. I'm gonna run this. So first I'm gonna figure that out. Think about collation or frequencies. I have to look at the other ranges as well to see if it makes the other ones make sense, because that will allow me to have a higher degree of trust that it is an accurate representation, but then to use on the simulation I just have to change the calculation there. Maybe multiply by a number, maybe round or something like that. Or I'm doing the wrong calculation there to get the frequencies, but the proportion is correct. Do you have better represent frequencies of range? Get bats. Yeah, I think I have 73,000 hands only here on this sample. That's the problem. I can need more, a lot more. And if I had the hands with whole cards as well, that would be a lot better as well. Because then I would be able to actually see all the hands without losing the information until for the ones that they get to show now with. And I think I might have those hands on the external hard drive, so I'm gonna look into that later. So it's algorithm your GATs simplified bat sizes. For flop, turn, and river. Yeah, here the effective stack is 24. Because I think there's 10 NL, 15 NL, and 25 NL hands on this sample. So you can see the effective stack here is 24, and 29, 30. And this varies as well because of the other player. Because in Bulldog they allow you to buy in with a lot smaller big blinds. So some people buy in with 7.5 on 25 NL. And I'm getting the effective stack based on the smallest one, obviously. But the thing is that you shouldn't change the bat sizes based on because it's based on the pot size, not on the effective stack. Yeah, looks there's only... Yeah, this dictionary doesn't contain the frequency, it's just the effective stack, so it ranges from 50 to even 4, I think. Oh, there's also some situations where people lose stacks and they keep playing, so like someone enters with 7.5 but then they get down to 3 and they still play, so in that case the effective stack would be 3. So it varies a lot. Yeah, but now it looks like it is correct. Maybe it's because I don't remember if I tested. Yeah, I think I didn't test it converting to a percentage on this file. After I changed this range here to use this delta, I didn't change back to a percentage. I was using just the raw value. But now it looks like it's very clear here. Huh, very interesting. Nice. So this means that the ones used the most are 67, 40, 14%, 8%, 3 or 4, and 141, and then 1.6. Yeah, these ones are almost never used. And these are the villain bat sizes. Huh. Nice. This is actually very nice. So I'm gonna use these bat sizes here to... Oh, this is bat sizes on the flop as well. So I'm gonna get, I might as well show it here because I'm probably gonna do this on stream to build the simulation, to build the other parts of the... I think I wanna do this part on stream, figure out how to have the connection between the two, because it's gonna be hard and I think it's gonna be interesting as well. Might even try to incorporate machine learning, should be very interesting. Like a convolutional neural network to get, but what I think I'm gonna end up doing is just the inputs and outputs stuff that I talked about earlier. Let's create a bunch of different ranges and then create a bunch of different and save on the file. I'm just gonna put the range, don't put anything else on the thing. I don't know, clear all. So I'm just gonna put one of the ranges and then save here, and then this is gonna give me, I think, range tasks. Let's see if it gives the... saves. No. Oh, so it doesn't show. So how did I do this one? I think I need at least some bats there. Actually, let me do like this. And put just these ones. Yeah, there we go. So this is what I'm probably gonna do. Like create a bunch of these and then like because I can select specific cards, I can just copy this enough times and then I can map out like what are the positions of each card. And I think I don't even need to create a matrix. I can just do a one-dimensional like a line. So I create this as I put this on a string and then I loop over the string. And then I do this enough times until I get the pattern of where each hand is. I have to make sure as well that I'm changing the suits of each hand. But this might be too difficult to do because it might take a lot of repetition and a lot of testing, so I might have to think about another way to do it. But I think I want to do that on stream. And then after that, there isn't much else, I think. After creating the simulation, then obviously there's going to be a lot of other stuff that I'm going to think about doing. But I think before it's just this, up to the point to create a simulation. Then I can use these bat sizes that I have here, put them on here, and then save the file. And then the only thing that I have to do left is to figure this out. And then the rest I obviously gonna put like this, and then I'm gonna accept as parameters here. And this is gonna come from the analysis part here, where I'm gonna extract all the information. At the end, I'm gonna put everything's gonna be on the sim class. And then from the information of the sim class, I can put the values on the strings here. And I'm gonna have to study the UPI as well, because I know how to build, but I don't know how to save the trees, or how to run the solver. And it's hard to... because there might be a lot more commands that you have to do, which might be annoying, so I think... yeah, it might be the case that I will still have to do a lot of other stuff to make it work. And I have to define exactly what I know, what I need what I want to do with this. I want to create the simulations. I think the main priority is to use the data to create exploitations based on the Nash equilibrium. So it's like I'm using Pio to read what are the imbalances of the data and to create simulations that exploit those imbalances. That's the main thing that I'm trying to do. And then once I have the simulations, I can train on the simulations. But then there's a lot of nuance in that, obviously, because like how do you define what parts do you exploit? How can you use the data to node lock the simulations? I think that's the hardest part. Yeah, nice. So here it looks like there isn't a lot of bats actually. I think it's something that changed. I probably changed it's probably the delta, because there was a lot of small variations of each bat. So by using the delta, it simplifies a lot. And it looks like most people use 42% in the turn, 14%, and 6, and sometimes 4 bats. Sometimes this is probably the mean bet a lot of people do, where they just bet like a big blind in the turn, kind of like a block bet. A lot of people do that. 1%. Nice. Yeah, so I'm gonna stop here. I'm not sure. I'm probably gonna come back today. Maybe I'll come back tomorrow only because I have to work out. I think I'm gonna eat, then go work out. Then if I not exhausted by then, I think I might come back and try to figure the other stuff out. And I'm gonna think about these things here off stream as well. But if I don't come back today, I'm probably gonna come back tomorrow or Monday, up to Monday, I think, very likely. So